Alright, so we're going to continue talking about factoring, and we're going to talk about factoring as a product of binomials. We already talked about that in the case where your leading coefficient was 1, so you're looking at, for example, x squared as your leading term. So now we're going to look at, what if that first term isn't a 1x squared? What if that leading coefficient isn't 1? Then that makes things a little bit more complicated. So before we talk about how to factor it, I want to explore multiplying a product of binomials out, and so we can see where everything goes in the relationship of different things. So here I'm going to look at the situation where I'm going to take 2x minus 7 times the binomial 3x plus 5. And we're just going to do that our normal distribution, 2x times 3x, 2x times 5, negative 7 times 3x, and negative 7 times 5. And it's going to give us this expression, 6x squared plus 10x, and then negative 20x and negative 35. Combining the 10x and the negative 21x gives us negative 11x. Now, I color code this so we can see how these numbers are kind of merging together. Notice, we have the x and the x, those are the red. You can kind of see how the red kind of filters through the problem, attaching, you get the x squared term and then two x terms, and those two x terms combining together. You notice the blue 2 and the blue 3 multiply together to make the blue 6. So the 6, when we look at that final expression, that blue 6, we're thinking, oh, that comes from the numbers at the beginning of each of our binomials. And then the negative 35 in yellow at the end of our last expression, we go back and we see, oh, negative 7 and 5, those are both yellow. That's where it came from. So that negative 35 is formed by the end values in each of our two binomials. And then the negative 11 is formed by combining the blues and the yellows. Blues and the yellows making green. So the 2 and the 5 making a green 10, the negative 7 and 3 making a green negative 21. Those two combine and make the negative 11. So that middle term is formed not just by the end term, the negative 35, but it's formed by the mixing of the beginning and the ends. So this, what goes into 6 and what goes into 35, those mix together to make that green 11, negative 11. So we're going to go with that understanding that that middle term is formed by a combination of the beginnings and ends, and that's going to be the trick to doing this kind of factoring. So let's look at the middle expression. If we take those two middle terms, 10 and 21, and I'm not going to worry about the signs for right now, that's another issue, but if I just take 10 and 21 and multiply those together, I get 210. Now, if I go and I look at 6 and 35, those also multiply together and make 210. And this is always going to be true, that the leading coefficient, that's 6, and the constant term, that's 35, are going to multiply together to make the same product as what the two middle terms were before we combined them would multiply to make. And that's going to make a connection to how we're going to factor this. So now that we know how this multiplies out, let's show how we would approach factoring it. And so I'm going to start, like as if I didn't know everything that I just talked about, that I already know this how it's going to factor. I don't know that this is 2x minus 7 and 3x plus 5. I just know I have this. So what I'm going to do is I'm going to realize, okay, that 11 is going to be formed by combining things from 6 with things from 35. Things that go into 6 and things that go into 35. And so I'm just going to multiply those together. And I'm going to ask myself, what are the factors of 210, and I got 210 by taking 6 times 35, that are different by 11? So this is kind of like what we did when it was just an x squared term at the beginning, except we don't just look at the last term, we look at the product of the leading coefficient, the 6, and the constant term, the 35. And we're going to use that product to ask ourselves this question. And so I'm going to go through all the factors, all the different pairs of factors that make 210. And so here's a complete list of those whole number factors. And I'm just going to go through and start, eliminating pairs of here. So I'm looking for ones that are different by 11. So 1 and 210, those are different by 209. 2 and 105, those are different by 103. 3 and 70, those are different by 67. 5 and 42, those are different by 37. 6 and 35 are different by 29. We're getting closer, we're getting less each time. 7 and 30, those are different by 23. 10 and 21 are different by 11. 14 and 15 are different by 1. So we find the combination is 10 and 21. Those are the ones that are different. And just like before, where we, because that last sign is a negative 35, that's telling me these are different. And the fact that the middle sign is a negative 11 is telling me the larger of the two numbers I just found is going to be negative. Now, I'm not going to write those numbers in my parentheses, not like I did before. Instead, those are the two middle terms. If you think about like you hear FOIL, those are the O and the I terms. And so what we're going to do is we're going to tear that negative 11 apart and make it into these two terms. We're going to basically work what we did in the original part of this slide backwards. Instead of adding them together and getting negative 11, we're going to tear them back apart and get a separate 10 and a separate negative 21. Now you might wonder why we're doing that. Well, if I look at this, I now have 4 terms. And there's a type of factoring that uses 4 terms, and that type of factoring is grouping. You can pair these up. So I look at the first two and I ask myself, what is the GCF? What is the largest number that goes into 6x squared and positive 10x? And that answer is 2x. And so if I factor a 2x out of those, I get 3x plus 5. And we said, back when we talked about grouping, we said that whatever you get in that first parenthesis, you have to get in the second parenthesis. That's the only way it's going to work. So it's got to be a 3x plus 5. And I just have to figure out what I need to factor out of those two. So the easiest way to do that is take negative 21x and divide it by positive 3x, and that would give, the x's would cancel out, and that'd give you negative 7. And we can check that. Negative 7 times 3x is negative 21x. Negative 7 times positive 5 is negative 35. So this is going to work. Common factor here now is 3x plus 5. And so it's going to be 3x plus 5 times the other part, 2x minus 7. And again, you could write that in, 3x plus 5 first and 2x minus 7 second. That's fine. So this is going to be the trick to this, the method of approaching this. Is we're going to say those two middle terms were formed by parts of 6 and parts of 35 merged together, and we're just going to put them all together, 6 times 35, and then we're going to split it up into what those different groups would be. What are those middle two terms were before we combine them. So let's look at this problem. 4x squared minus 21x plus 27. So again, we're going to take 4 times 27. We're going to ask ourselves, what are the factors of 4 times 27, so 108. And notice that's a positive 27, so we want to know their sum, that is 21. So what things multiply and make 108, but if you add them, you're going to get 21. And so again, here's a bunch of whole number, here's all the whole number pairs, and we're just going to go through and think about if we add them together, which ones give us 21. So 1 and 108, those give us 109, 2 and 54 gives us 56, 3 and 36 gives us 39, 4 and 27 gives us 31. Again, we're getting lower, we're getting closer. 6 and 18 gives us 24, 9 and 21, or 9 and 12 gives us 21. There's our pair. And so again, same signs, both negative. This is where the overlap of what we've already talked about is coming into play here. And so we got 4 terms here. We're going to group these up. Look at the first two. What do those have in common? X, take that out. Get a 4x minus 9, which means you need a 4x minus 9 in the second part. Negative 12x divided by 4x, negative 3. And so our matching part, 4x minus 9, and then the other part, x minus 3. Is our two factors. Let's look at this one. Okay, well this is a little different. It's got y's in here now, but the process is the same, because really the difficult part here isn't necessarily the letters, it's these coefficient values, these 15, the 14, negative 8. So, first thing we want to do is double check everything's in the correct order. Is there a GCF? And no, 5 and 3 go into 15, but those don't go into necessarily 14 and 8, and 2 and 7 go into 14, but 2 and 7 don't go into 15, so it doesn't have a GCF. But we should check. You should always check. And so we're going to take the 15 times the 8, and we're going to say 15 times 8, whatever that is, what are the factors of that are different, because that's a negative final term. So what are 15 times 8, what are the factors of that product that are different by 14? And so 15 times 8, that's 120. So what are the factors of 120, whose difference is 14? So we go through all the factors of 120, and we're looking for ones that if you subtract them, you get 14. So 1 and 120, those are different by 119. 2 and 60 are different by 58. 3 and 40, 37. 4 and 30 are different by 26. 5 and 24 are different by 19. 6 and 20 are different by 14. 8 and 15 are different by 7. 10 and 12 are different by 2. And you'll notice you only ever get one pair. There's not a situation where you're going to get 6 and 20 and then someone else. So, if I was doing this by hand, as I was working the problem, as soon as I hit that 6 and 20 pair, I wouldn't bother with the 8 and the 15 or the 10 and the 12. I'm just putting them here as, to be complete, make my list complete. But, as soon as you hit a pair that works, does what you want it to do, you're going to stop and use that pair. So, again, they have to have different signs, and because it's a positive 14, the larger of these two, between the 6 and the 20, has to be positive, and those are going to be our two middle terms here. So this is going to look like 15x squared minus 6xy plus 20xy minus 8y squared. And notice those two middle terms have to be the same, have to be like terms. So because that it was a 14xy, they both had to have an xy on them. They have to be like terms so that they would have combined to make the 14. And so again, we're just going to, got 4 terms, we're going to group them up. First two, they both have an x, and 3 goes into both 15 and 6, so we'll take out a 3x, get 5x minus 2y. Again, we need a 5x minus 2y in the second part. 20xy divided by 5x. 20 divided by 5 is 4. You knock the x off, you still got a y, so 4y is a common factor. And factor the 5x minus 2y out of here, and you get 3x plus 2y as your second binomial. Alright, so let's look at this problem. This is going to be the final one for the standard way of factoring these. I'm going to then, after this, talk about some other methods you can use. They're pretty much the same thing, it's just the writing is going to be a little bit different. But so let's look at this one. So I look here, and I notice, hey, 45, 120, those are all multiples of 5. And everybody has at least one x, and everybody has 2 y's. So this is a situation you should always approach a problem by starting off by asking yourself, what's the GCF? And again, it's got to go into everybody. So here, 5xy squared is a GCF. Notice that doesn't get rid of my entire leading coefficient. I ended up with still a 9x squared. You can't use a GCF if, to eliminate your entire leading coefficient unless that is actually the GCF. There's no shortcut way of doing what we're doing today. So I'm going to look here and say 9 times 4 is 36. What are the factors of 36? Whose sum, because that last term is a positive, is 20. And because the middle term is positive as well, when I find my pair and I put them into this expression, they're both going to be positive terms. So let's go through the factors of 36. I want to know which ones I add and make 20. So 1 and 36, no. 2 and 18, there's 20. So nope, nope, nope. Those other 3 don't work. And so I'm going to rewrite this. Notice I still have that 5xy squared sitting out front. That's going to be part of this entire problem the rest of the way through. Do not drop that GCF off of the problem. So I'm going to look at what's inside the brackets here. And again, I'm just going to group them. First 2 have x in common. So I factor that out. I get 9x plus 2. I need to get a 9x plus 2 on the second half. Again, 18x divided by 9x would be a positive 2. So I must have factored out a positive 2 on the second part. What matches? The 9x plus 2, and then the other part, the x plus 2. And again, make sure you keep the 5xy squared on there. And there's our product of binomials. So that's the general method, I would stop here unless you feel like you want to look at maybe some more advanced approaches to doing this. But they're all pretty much the same, and if you could do this is a good way to do it. All right, so let's look at a slightly more advanced way of approaching a problem like this. So it's going to start off exactly like we've done before. We're going to take the 12 times the 75, get 900, whose sum is 68. And we go through all those pairs. And there's a lot, 1 in 900, 2 and 450, 3 and 300. And we're looking for which ones add up to be 68. No, no, no. That's 100. That's 87. That's 75. 15 or 18 and 50 is 68. Okay, so nope, nope, nope. There's my pair. And so those middle terms are going to be negative 18x and negative 50x. Now I'm not actually going to write that over there. Instead, what I'm going to do is I'm going to try to go straight to the factoring. But in order to do that, I have to be able to, this is kind of a more intuitive approach, is you pick one of these numbers to make. And I'm going to make the negative 18x. And I'm going to ask myself, what are the pairs of things that multiply and make 18? I'm not going to worry about the sign just yet, but what makes 18? And so I ask myself that, and I come up with this list. 1 and 18, 2 and 9, 3 and 6. And I start thinking about which of those would have something that I could use from 12, some multiplier from 12, and some multiplier from 75. So 18 doesn't go into 75 or 12, so that one's not going to work. 2 and 9. Well, 2 does go into 12, so I could use that, but the problem is 9 doesn't go into 75. Well, what about 9 going into 12? Well, no, that doesn't work. So I have 3 and 6. Well, 3 goes into 12. That would work, but 6 doesn't go into 75. What about if the 6 went into 12? Yeah, 6 does go into 12, and 3 does go into 75. So what I can do is I can say, I'm going to make it 18. And the way I'm going to use that is I'm going to take a multiplier from 12 and a multiplier from 75. And I'm going to use a 6 that goes into 12 and a 3 that goes into 75. And that's going to be my outer terms. So you think about FOIL. Those two middle terms are the O and the I, the outer pair and the inner pair. So I'm going to find the outer pair, which is going to be the 6x times 3, and I want that 3 to be a negative because I want that to be a negative 18. Once I've found this pair, once I've found a way to create one of the two numbers I wanted to make a negative 18 and I wanted to make a negative 50. Once I found one way to create one of those numbers using numbers that go into the front and the backs, then that will tell me what the rest of this has to be, because I know first times first has to be the first thing. So 6x times what is 12x squared, and that has to be a 2x. 6 times 2 is 12, x times x squared. And I know last times last has to make last. So negative 3 times what will give me a positive 75. Well, it has to be a negative, and 3 goes into 75 25 times. So it has to be a negative 25. Now, remember, I started this off by saying I was going to make my outer pair. Now let's think about what the inner pair would be. Negative 25 times 2x would be negative 50x. There's my other pair. 50 can be broken down as a 2 times 25. That's how that factors. So this way, I may not write down all this work if I was doing this, but I would definitely be talking to myself and asking myself, okay, once I figure out I want to make an 18 and a 50, what's a way I can use things that go into 12 and 75 to make one of those numbers? And maybe it might have been easier for you to make the 50. Maybe you might have said, oh, I know I can get a 25 out of 75, and I know I can get a 2 out of 12. So, maybe you would have started by trying to build the 50 and not the 18. But it will work either way. Once you find one pair, though, once you find the outer pair, you can build the inner pair. Just by first times first makes first, last times last makes last. So that's a different approach to do it. It's a little bit more intuitive, a little bit more being able to look at numbers and break them down into pieces mentally, but that's an approach you can use. And let's look at a third approach. So this one is a little bit even more advanced. way of looking at the problem, though I think it's a little longer maybe, but it's more advanced way of looking at it. And what it says is, notice that 6x squared. Well, let's make this into a fractional expression and multiply the top and bottom by that number, whatever that first number is. And so what that's going to give me is 6 times 6, x squared, and then 6 times 13 and times x, and then 6 times 5. And the way I'm going to write that is this way. Remember, 6 times 6, x squared, is the same as 6x, that whole quantity being squared. And then 6 times 13 times x, well, I can put the 6 and the x together. So it's 13 times 6x. And then 6 times 5 is 30. Now, why would I want to do that? Well, by writing it this way, I can look at this as something squared minus 13 something, minus 30. And this is now more like the x squared minus 13x minus 30 problems we looked at before. And so I can now just look at that last term and ask myself, what are the factors of 30 whose difference is 13? And I go through those factors. 1 and 30, they're different by 29. 2 and 15, hey, those are different by 13. So nope, those don't work. And instead of doing the grouping method and everything, I can just start writing my parentheses and put those 2 and that 15 back there, and the bigger one has to be negative. Now, the problem with that is, what I want to do is have this in its most simple form. And notice when I look at 6x plus 2, I basically split that. I said, oh, I have 6x squared. This is 6x and 6x. In both of those. No, 6x plus 2, they have a 2 in common. And 6x minus 15, they have a 3 in common. So I'm going to factor out that GCF. And then I'm going to say, well, hey, look, I got a 2 times a parenthesis times a 3 times a parenthesis. So I have a 2 times a 3. Those two can cancel out the 6 in the bottom. And I get the 3x plus 1 over 2x minus 5. And that will give me the original expression back. The idea here is to kind of create this problem more like how we did the first set of products of binomials, where you have something squared minus 13 something minus 30, and factor it that way. It does require you to do more breaking things down, factoring out GCFs at the end of this problem to get down to the final answer. But this is another approach. And sometimes people, they just put the 6x and 6x, and they don't put the divide by 6. They just knock it out, the 2 and the 3, as they go along. One big danger to this method is if there's a GCF, it can make things even more complicated if you don't catch the GCF. So watch out for that. But this is another approach I've seen people use, and you're free to use it. It's not one that I would strongly recommend you use.